So, okay, right off the top on the quiz preview, I'm going to throw a curveball at you. I'm going to go back to right triangles for a minute because it's been within our trig unit, so I mean it's fair game, it's not that old. But use the pattern of special right triangles. Uh-oh, we got to remember those again. To identify the missing sides. Remember, when you have a 45, 45, 90 triangle like we do here, there is a base value to those particular triangles, which is the legs will be the same value, and the hypotenuse will always be that leg value times the square root of 2. We talked about this when we were doing the right triangle trig. So if I understand that, this is going to be fairly easy. Because I look at this and I say, well, hey, if this is 6 times the square root of 2 and it's my hypotenuse, and that's x times the square root of 2, it's just 6. So I just put 6 in both of those and I'm done. I go on to the next problem. Now, if I don't know that, that's going to get a little complex. Because how the heck am I going to find the legs when I just know the hypotenuse? It can get tricky. When I do that again on number 2, a little bit different. Because now I've got a 30, 60, 90, which is the other one we talked about. That one, my x value always was across from the 30. That's my short leg. My long leg was x square root of 3, so opposite from my 60. And my hypotenuse was 2x. And again, we did this in notes. We did a worksheet on it too. Now this one I'm going to have to do a little more work because you'll notice my legs aren't going to be the same this time. So I look at this and I say, okay, what piece of information do I have? Well, I have the hypotenuse is 8, which is the equivalent of this 2x side. So if I do just a little bit of algebra here, I find out my x value is 4, which gives me the short side. And again, remember it is the short side is opposite of 30, because I'm not guaranteeing on the quiz tomorrow that I'm not going to flip this triangle over. So don't just think, oh, if it's on the right, don't do that. The opposite of 30. My long leg, okay, which is the opposite of 60, is that x value with the square root of 3. So without understanding those special triangles, you're not going to get these right. Because, well, unless you're really good at guess and check somehow, which would probably take a while. So those are 2 things you wanna lock down on if you'd forgotten about those for a bit. Some of our other parts, I'll move this up just a little bit. Find the value for the following trig functions. Identify what quadrant the terminal side is in. Okay. So that's one thing I got to do. What sign the function should have in that quadrant. We'll talk about that in a minute. Then use special right triangles to find the value. So there's 3 things going on here. Now, if I want to, and again, for this, if you just sketch it, that's fine. If you have your little, one of these still, your little protractor, that's cool. But otherwise, if we sketch it, that's okay. So here's what I've got to remember with these. Okay. Here's my initial side every time. Whether it's a positive or negative angle, we always start here. And so as I go around, I'm like, okay, 90, 180, 270. I look and I say, okay, to get to 330, I need another 60 degrees. Now again, whether you use the protractor or you just kind of, guesstimate it here, okay, I don't care. But here's what I need to remember. If that part is 330, okay, first things first, what quadrant am I in? The 4th. Okay, so quadrant 4. That's my first deal. Because remember, my quadrants go 1, 2, 3, 4. So I've got that part. What sign the function should have in that quadrant? Now, that's another thing we discussed before. We talked about how in quadrant 1, all of my trig functions are positive, but we're not in quadrant 1. We talked about how in quadrant 2, sine is what's positive, but again, we're not in quadrant 2. Third quadrant, tangent's positive. But we're not. But right, when we get to quadrant 4, it's cosine, and this is cosine. So it should have a positive sign. So I know that. I got 2 out of the 3 questions done. Then use special right triangles to find the value. Okay, I'm going to jumbo size here for a minute. So what that means is, if it's 330 to here, and it's 360 to get back, what is my reference angle going to be? How many degrees do I have left in this little spot? 30. So, there's my triangle. This is 30, which is what I'm basing everything off of. And this is 60. And you're like, oh, so it's like this. Right. Except when I'm doing it in one of these, you're like, but I don't have any values to work with. We're just going to use 1s in all of those x spots. So if I was just looking for a basic 30, 60, 90, and I don't have values to work with, my side opposite 30 would be 1, just like it was before. So we're just going to replace the x's with 1s. My 60 would be the square root of 3. And my hypotenuse is going to be 2. And that would be true for any 30, 60, 90 that I do when I'm doing it with a trig function in a circle like this. So I'm being asked for the cosine. So let's see, cosine. What sides do cosine use? Okay, adjacent and hypotenuse. So since this is the angle I'm working with, here's my adjacent side. So I'd have the square root of 3 over hypotenuse, which is 2. Now I'm going to warn you in advance. I'm not accepting decimal answers. So if you decide you're going to try and shortcut it and just type it in the calculator and hit cosine 330 and write down, let's see, what would that be? 0.8660, that's not going to work. So you've got to play with this a little bit, okay, and do some of the different steps to get there. So we're going to do the same thing on the next one. There's going to be one other little twist, but we'll tackle it. So cosecant of 135. Okay, 135. Let's see here. So there's 90. How many more degrees do I need to get to 135? I thought I heard it. 45, which is right dab in the middle here, okay? So there's my 135. So I can answer my first 2 questions already. I notice that I'm in quadrant 2. Got that part. I also notice all students, now be careful, cosecant, what's its base trig function? In other words, what's its inverse? Which one of these does cosecant go with? Sine. Okay, so when I'm thinking about these, this is going to be sine and cosecant if I get one of those inverses. This would be tangent and cotangent. And this one would be cosine and secant, and that's where they're positive. So I notice again, okay, quadrant 2 is where sine and cosecant are positive. Okay, so this is going to have a positive sign. If it would have been in quadrant 3 or 4, it would have been negative. But this one works. So I continue this, and I say, okay, I need to know my reference angle. Well, that's to get me back to here. So to get back to my x-axis, I just subtract these. 180 minus 135 means I'm going to have a 45, 45, 90. So I get a little bit of a visual picture to go along with it. My 45, 45, 90, if I scooch down just a little, again, we're still replacing the x's with 1s. So both of my legs would be 1. And then over here, my hypotenuse is the square root of 2. But again, I got to know my forms to be able to do that. So I look and I say, okay, cosecant, ooh, cosecant is 1 over sine. So let's do sine first, and then we'll figure out what the answer is. Let's see, sine is opposite over hypotenuse. Okay, so sine is opposite over hypotenuse. Uh-oh. We have a radical in the denominator. How do I fix that? How do I rationalize it? Yep. If I multiply by that radical, the square root of 2, I get the square root of 2 over 2. But let me think about this for a minute. We just got done saying that cosecant's the inverse of sine, right? So if this is what sine is, and I flip it, what would it become? So this is what I need to do. I want some of you to think about the fact you'd get into sine and you'd be so interested in doing this that you'd have that and then you'd flip it and you'd be back in the same situation. So here's what I want you thinking about. If I do my sine, I want to stop for a minute and go, wait a minute. Cosecant's the inverse of this. If I flip this over, I don't have to do all this stuff because if I flip it, I don't have the problem anymore. That's the thought process. We're trying to get into critical thinking with this. I don't want you to just be kind of following along with things. So that's how I could deal with that. And again, if you did do this work, you'd find out when you flipped it, you'd have to rationalize it again. You'd still end up with the same answer, though. You'd still get the right answer, just take you a little longer. All right, I got to zoom back out here. Can I zoom one more? Nah. All right, here these guys come again. Did I mention we need to know these? Yes, we need to know these. Need to know them, need to know them, need to know them. Because when I start doing this, now I got to start looking at what values I have for different things. I look, I'm like, okay, there's my A value, there's my amplitude, which means I'm going to be taking my Y values, I'm going to be multiplying them by 2 when I get done. But here's my bigger thing. This theta over 2, remember, if I wanted to write it this way, I could. Theta over 2 just means it's 1/2. It means my B value is 1/2. What does that mean? Remember, to us that means we take our period, 2 pi, we divide it by 1/2. Now remind yourselves, if you divide by a fraction, the value gets bigger. 2 divided by 1/2 is 4. So my new period is going to be 4 pi. So when I do look at making a chart, if I want to go that route, what I'm going to be doing is I'm going to be, remember, divide by 1/2, same as multiply by 2. I'm going to multiply every one of these base measurements by 2. So 0 times 2 is still 0 last time I checked. Pi over 2 times 2. Now think about that for a minute. Pi over 2 times 2 is 2 pi over 2, which is just pi. And you're going to see a pattern develop here in a minute. 2 times pi is 2 pi. What do you think 3 pi over 2 times 2 is? Look at the pattern. 3 pi. Now, would I still get it if I actually worked that out? Sure, I would. I'd look and I'd say, okay, if I wasn't sure, 3 pi over 2 times 2 is 6 pi over 2, and 6 divided by 2 is 3. And then 2 times 2 is 4 pi. Because this last value always matches up with what my new period should be. So you're like, okay, It's cosine. So I would normally start at 1, but remember, my amplitude is 2. So I'm going to times all these cosine values that I already have locked in here by 2. So 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 and 2. Now here comes your next dilemma. You're like, Harty, why are you messing with these things? It only goes to 2 pi. Okay, here's what we're going to do. We're going to adjust. So let me move this out of the way. Normally what I'd tell you to do is I'd say we'll just head towards negative 2 pi, but I'm not going to put you through that. So I look and I'm like, okay, so this is 1 and this is 2. So I'm at 0, 2. And then when I get to pi, I'm at 0. Then when I get to 2 pi, I'm down at negative 2. You're like, well, what do you want me to do from here? For our purposes, it's not going to be perfect. But again, we've got to learn to adjust when we get a twist thrown at us. So we'll just make it work. 3 pi, we're back to 0. 4 pi, we're back up to 2. And again, try to work on, these are curves. Curves, people. When you look at it on your calculator, it doesn't look like V's everywhere, okay? So we're going to want to get curvy a bit. But as long as you label, and again, don't just put 2 lines out here, okay? Let me know what they are. Showing me the table would help. But that's how we do this. It's not something doing on the calculator is easy because you don't get the right values working. And the only difference we'll see when we get to number 5 is going to be now my period value is going to change a bit. I ended up with the same amplitude, 2, but now this time, since my b value is 2, I would take my period, divide by 2, and get my new period of pi. So, you're like, oh, so I'm just cutting all those values in half is what I'm doing basically, which is absolutely true. So we bust this guy back out. Now this is, you're visually getting to see what's in your brain. Now I don't think I need to get cute with this and multiply everything by half. We're cutting things in half. Half of 0 is still 0. Half of 1/2, half of 50 cents, half of a dollar, is 1/4, or pi over 4. But if I wanted to do the side work, if you're more comfortable with that, you're going to multiply these by 1/2. Half of pi is pi over 2. 1/2 times 3/2 means I'm just multiplying the denominator by my value. So 3 pi over 4. And then half of 2 pi is pi. And it matches up with my period. So I feel, okay, I did this right. And just like we did on that last one, my only job is going to be to multiply the y value of sine by 2. Make sure you get the right one. So if I multiply 0 by 2, I still get 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. 0 times 2 is 0. And it's actually all going to fit this time. It's even better. So I'm like, okay, 0, 0. Oh, pi over 4. I don't see pi over 4. But we just got done saying pi over 4 would be between 0 and pi over 2. So label the tick mark. That's all you need to do. Get that up there. Pi over 2. We're back to 0. You'll never guess where 3 pi over 4 is. It's right in between pi over 2 and pi. And I'm going to put a big dot right over it right now. And then back to 0. Curvy. So when the period gets bigger, we squish. When it gets smaller, we expand. So that's, again, how those work. But it all comes back down to, oops, do you know these? If you do, piece of cake. If you don't, you got about 24 hours to figure it out. All right. To the back for our other two types that we did. Now life gets simpler. Sine theta minus 3. Minus 3, not in the parentheses. Which means we're going to shift down 3. Or in other words, we're going to take the y value and minus 3 from it. So my base values aren't going to change this time. So life is simple as far as that goes. But now my y values for sine, I'm going to subtract 3 from all of them. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. 0, we're back to negative 3. Negative 1 minus 3 is negative 4. 0 minus 3 is back to negative 3. So my whole graph just shifted downward. So I got 0, negative 3. I don't even have to use the extra little tick mark this time. Curvy. So it's my exact base graph. I just shifted it down. But again, all comes back to knowing your base. Then the last thing we'd done was our left and right shifts, okay, our horizontal shifts. Remember, they're trying to fool you. This is the one where it's a liar. It's the opposite of what you would think. You would think minusing pi would mean you'd move left pi, but it's not. We're moving right pi. It's the exact opposite of what comes out of its mouth, which means I'm going to add pi to my angle measures. Okay, my y values don't change on left and right shifts. So I look at this and I say, okay, so I'm going to take my bases, these guys, and I'm going to add pi to all of them. Now we had a discussion before about how this is going to work. Most of you are okay with the 0, 1. And you're okay with this one because pi plus pi is 2 pi. And this one you're okay with. 2 pi plus pi is 3 pi. But then trouble starts. I don't know what to do with the one in the middle. Who knows? Can I just put like, because I talked to some of you and I'm like, well, okay, what's like a half? What's 1 plus 1/2? You're like 1.5, but you don't write 1.5 pi. We just don't do that. If you don't know what that is as a mixed number, well, an improper fraction would be a better way of putting it. 1.5, if you do math, enter, enter, if you have to, you plug in the calculator, you hit math, enter, enter, it says 3 over 2. So that would be 3 pi over 2 would be that value. When you get down to here, if you have to, you punch in the calculator. 3 halves, in parentheses, plus 1. You hit math, enter, enter. You get 5 pi over 2. Okay. No decimals. No decimals, no decimals, no decimals. Once I get that part done, the rest is simple. Because cosine, I know the values already. They're drilled into my brain. And they haven't moved. All I've done is shift my graph to the right. So I look and I go, okay. So at pi, I'm going to be at 1. At 3 pi over 2, I'll be at 0. I see trouble coming. At 2 pi, I'm going to be at negative 1. You're like, Harty, I ran out of room. We're going to do the same thing we did before. 5 pi over 2. 3 pi. If we run out of room, we run out of room. We deal with it. 5 pi over 2, 0. 3 pi, 1. curvy. If you have a grip on your base graphs, graphing isn't bad. But that's going to be your key. We can use the calculator for a few things, but notice we didn't break out the calculator once to do anything as far as the graphing itself went. And that's the better way to do it anyway. Then we get to our pals that we've been working on for the last 3 days. You're going to have a couple where you're doing identities and you're verifying them, and a couple where you're simplifying, where you're not sure when you're done. Remember, for the most part, when we get down to a single term, we're done. So I start looking at these two. Let's see if I move this up a little bit here. Sine squared plus cosine squared plus cotangent. Now my initial idea would be to look at this and say, leave it alone, leave it alone. Ooh, I'm going to change that into cosine over sine squared. But then I look back for a minute, I'm like, I see all these pluses and things. Now there's got to be some way, let me do the opposite here and move this down. Ooh, perfect. There's got to be something that I could get helped out with here. Ooh, wait a minute. Pluses and minuses are usually there for a reason. Sine plus cosine is 1. So this is 1 plus cotangent squared. Then again, I look and I go, ooh. My temptation again is to turn this into sine, cosine over sine, because Harty kept saying try to get everything into sine and cosine. But let me take one more look, just in case I happen to see this exact thing somewhere. Ooh, I do. It's right here. Oh dear. You are going to be given a sheet that looks exactly like what you see here. Yep, this is the exact thing. Now, again, notice like I'd mentioned at the start, I'm not doing all of the different movings and things like we've had up on the board and stuff. If you want to write a few just to remind yourself of what they are, that's fine. You can do that, adjust them, do anything you want. But what you see here is what you're going to get as far as tomorrow goes when we're doing the actual quiz. So I get down to one term, I'm done. I don't want to turn this into like 1 over sine squared or something like that. If you get to a single term, you're good. So I get to 9, and I go, okay, number 9. Let me try to get everything fit back in here again. Tangent. Tangent of x. Ooh, I see 1 over tangent. No, I already said I shouldn't try to use tangent. Sine over cosine. Okay. So tangent is sine over cosine, and then we normally don't touch sine. You're like, ooh, that's kind of a mess. We now have a fraction over a fraction. We're going to write it, though, in a way that makes sense. If you take a moment and write this horizontally instead, I bet you it will make more sense. So I'm taking the first fraction and dividing by what's in the bottom. But what happens when you divide by a fraction? What happens to the second fraction when we divide? It flips and becomes multiplication. So sine over cosine, and I'll flip this guy. Now, this is the time when I can cancel stuff. I can't cancel if it's plus, I can't cancel if it's divide, but once it becomes multiply, those guys are free game for me to whack away at. So once I do that, take it all the way to the end, 1 over cosine of x, I should be able to find an identity for that. Up at the very top, I see 1 over cosine is secant. Single term, I'm done. When I ask you to simplify, it's going to get down to a single term. It will, it will, it will. Those, to me, are the two trickiest ones because you're never quite sure what the answer is. However, when we get to the last two, I like these better because I know I'm not touching what's over here. I got to try and play to make this work. So let's see what we got here. Cosecant of x. All right, let's see here. Cosecant of x. I believe, is going to be 1 over sine. And you're like, now why aren't you looking at the minus for something? Because I don't see squareds. So I know it's not going to be any of the plus or minus ones, at least not yet. So 1 over sine minus. Cosine, we said we leave alone. Since I see another fraction somewhere, I'll put it over 1, play it safe. And then cotangent is cosine over sine. Now, before some of you who've drilled into your heads now, ooh, gotta have a common denominator, I see minus. Remember a couple of the things we've been talking about the last couple of days. You've got to watch order of operations. Times comes before subtract does. So I have to clean up what's in the parentheses before I can even think about subtracting things. So if I multiply through in the parentheses, cosine times cosine, don't cancel side to side, don't do it, is cosine squared. 1 times sine is just sine. And my day just got made. I already have a common denominator. I don't have to fix it. This isn't where I start trying to change things back around. It's where I turn this into one fraction, because then it may become a little clearer to me what I need to do. Ooh, now I do see a minus. Ooh, now I see a squared thing. Now I see a squared thing. Okay, let's see here. Let's see. What can I do? Maybe I can turn this into something. Let's see. 1 minus cosine. I could minus cosine over here. Oh, I just did something I didn't want to do. Oh, well. Let's see. Cosine squared. If I subtract that over... By subtracting that over, and this is one most of you probably had on your sheet already. Now, those match up, which gives me sine squared over sine. I gotta fix that. But if I take something squared and divide it by something like 1, we talked before about how that's like x squared divided by x, which would just be x. This is just gonna be sine. And they're the same now. I've got to see every step that goes through to get there. And sometimes you may have to go back and do it more than once. So this is probably one of those pencil type quizzes you're going to want to take, because if something doesn't work, we're going to go back and fix it. Now the last one, I saved a doozy. I did, I admit it. Because you look at this one, you're like, okay, I see squareds, I see a minus in the middle. So that tells me, more than likely, something is going to be going on. Might as well do it on here. With this. Now let's see. Tangent. So on my sheet, maybe I got tangent squared done here already. And this is what I mean when I say I may have to play with some of these things more than once. Because I start to look and I go, okay, how am I going to do this? How am I going to make this work? Or do I do sine over cosine? I just don't know. Where do I go? Where do I go? Where do I go? It may be one of those where I do it the first time and it doesn't work. So if some of you look at this and you go, well, I could try doing something with this and putting it in. Or I could try doing sine over cosine with squared and see how that works out for me. I can't tell you definitively that you have to do it one way or the other. Now I'll show you the way I ended up thinking of it, but you may end up thinking of something different. I want to make sure I do it the same way I did it on here. Okay, that's what I thought I did. So I decided I was going to try using, because I looked at that, I'm like, secant's not getting me any closer to this. So I'm going to try this. I'm going to try sine over cosine. Now, if I find out this doesn't work, I'll try something else. So minus sine squared x over 1. Okay, so I look at this and I'm like, ooh, this is kind of ugly. It's not nice like number 10 was. I need to find a common denominator. Ugh. Well, my common denominator, and if I got to do some side work, I do, is going to be the cosine squared of x. I'm like, okay, well, that's cool. First one I don't have to touch. It's the same already. Second one, we're going to have to play a little bit. Because now my job is to get from sine squared over 1 to something that's over cosine squared of x. And it's the same question we've been asking all along. What do I times this by to get to my new part? And it's that cosine squared of x. So you're like, so this numerator is going to be sine squared x cosine squared x? Yes. And surprisingly enough, we're almost to the answer. And also, surprisingly enough, no, I will not put one this tricky on the quiz tomorrow. But I do like doing this just to get you thinking again. You're like, we're almost there. It doesn't look like we're almost there. Here's the other thing that you can do. And we've done this with negatives, but we haven't necessarily done it this way. Okay, this is one term. This is a separate term. What do my two terms have in common? Sine squared of x. Okay. So I can take a sine squared of x out. I can factor it out. So sine squared of x times 1 gets me to sine squared of x. Well, 1. This times that gets me this. And then sine squared of x times what gets me to here? Well, I've already got the sine squared. I put the cosine squared in there. And now I get to get cute. Because I notice a couple of things. I say, hey, sine squared over cosine squared is tangent squared. And what's 1 minus cosine squared equal? And I'm done. I will not have one where you've got to factor and get crazy like that. I'm not that obnoxious. I didn't think it was bad to do on the quiz preview though. But the quiz itself will be the same size. Same number of problems. Same everything with this. So again, if you need to, go back and look at this. There will be a blank copy on there if you want to go back through it that way. Look through the other videos. And like I said, I put bonus footage on the online version of this, so you can see that too. So, just saying.